So let's go over the activity number 4 here to discuss all the solutions. When we try to identify the values of piecewise function, what you do is always you select your input, read the second half of expression and see which one is correct, or actually which one is the true statement. You check the true statement and use the first half of it to identify your value, which is -2 times 3 plus 1. So you can stop here, or you can tell me my final answer is -5. Well, what is not okay is for you to evaluate my function in both expressions and tell me you have two different values for a function, which doesn't really make sense. Another thing which is not okay but happens occasionally is you get super excited realizing 3 is greater than 2, and then you tell me my final answer is -2x plus 1. You should no longer have x in your answer because you have replaced it by 3. So be a little bit careful, make sure you do evaluation, and make sure you do evaluation in the correct term. So along the same line of thinking, 2 makes the first one to make sense, hence you have input plus 1 and you end up with 3. -2 makes the first expression to make sense, you have -2 plus 1. If you want to simplify, you end up with -1. In order to sketch the graph, I realized my function was cut at the point of 2, so I drew two different expressions, one on the left, one on the right, but they were separated at the point of 2. The one on the left is when x less than or equal to 2, the graph of x plus 1. When input is 0, my output is 1. When input is 2, my output is 3. And actually, when the output is 0, my input is -1. I do add this extra point because I want to make it super clear what exactly is my x, what exactly is my y-intercept, and where is supposed to be the point that I'm supposed to keep. Therefore, my graph is supposed to be something that goes like that, which is my first half of it. My other half is for x and -2x plus 1. So my input is 3. I end up with -5, which we found already. And if I were to have the input of 2, I should be having -3. So I'm having -3 here, and I'm having input 3 value -5, which is here. I do want to point out you want to use a solid circle here to express the fact that that point should not have been included, and this is the graph of my function. Just one more time, mark your boundary points properly, mark your x, y intercepts properly, so you can get full credit. The next problem is asked you to do function evaluation based on basic arithmetic calculations or function composition. So the first one essentially is asked you to do function summation. It's equivalent to add two numbers together like that. Hence, it's 1/4 plus square root of 4 squared minus 4 times 4. You can simplify if you want to, but you will get full credit once you stop there. Second problem, f of 8 minus g of 8, hence you end up with 1/8 plus square root of 8 squared minus 4 times 8. Again, you get full credit if you have stopped there, or you can keep going with your simplification. You end up with root 32. I would never require you to calculate roots of 32 by hand, and you are not allowed to use a calculator in task. So as a matter of fact, if you decide to find this out, I would say that's an indication you might have had academic dishonesty in the test. The next problem is f of -1 times g of -1. So you end up with 1/-1 times square root of -1 squared times 4 minus 4 times -1. You could have stopped here for full credit, or you could go ahead and modify it to end up with -√5. The last part is f of 4 over g of 4. So it's 1/4 divided by square root of 4 squared minus 4 times 4, which if you realize is actually 1/4 over there, 0, which does not exist. So this is not something that's well defined. The next problem is a function composition. So you are supposed to plug your function f at the position of x in your g expression. So this is what you end up with. And because you know exactly what's f, so you can simplify your problem like that. The next one is f composite with g, but evaluated at f. So what you're going to do is you're going to put g of 5 in there. Hence, you have 1/square root of 5 squared minus 4 times 5, which if you want, you could have simplified, but you receive full credit once you got there. So be a little bit careful. This one has x as input, so my final answer, I'm not replacing x by anything else. This problem has 5, so your final answer should only carry numbers. There's no variable. The last problem is it's g of g0, so you're plugging g0 into your function. So you have g0 squared minus 4 times of g of 0. If only you know what's g of 0. You can calculate it on the side. G of 0 is 0 squared minus 4 times 0, which is 0 minus 0 takes square root, which is 0. So you end up with 0 squared, 4 times 0, which you end up with 0, but you get 4 squared if you stop at the previous step, which means here. Okay, so the next problem is you want to add two functions together. Clearly, you want to make sure both of them make sense before you add them together. So in order to find the domain of f plus g, you want to find the domain of f, you want to find the domain of the function g, and find the shared region between those two domains. So both of functions can be evaluated. The first one has only a denominator, so you want your denominator to be non-zero. So your domain is negative infinity through 0, add to 0 through positive infinity. The second problem has a square root, so whatever underneath the square root is x squared minus 4x, and that should be greater than or equal to 0. So you can factor it, and you should be able to go ahead and use sign chart to evaluate this. If you still don't know how to use sign chart to solve inequalities, please go back, revisit our class videos for section 1.1. I think that's a very big issue if you still don't know how to do that. So your final answer is supposed to be x less than 0 combined with x greater than 4, including the boundary points. So if you were to combine those two pieces together, the shared region is anything less than 0 and everything greater than 4. So that's my final answer. The next problem where you want to have two functions to composite together, a naive way of doing it is to just put them together and discuss them. So what you have is what's f composite with g, which according to the definition is supposed to be 1 over g of x, hence it's 1 over square root of x squared minus 4x. This actually is a very popular mistake I've seen. So first of all, because I have a denominator, so whatever is my denominator should not have been 0. Secondly, because I have square root, whatever underneath square root, which was only x squared minus 4x, it's supposed to be greater than or equal to 0. Be very careful about which part is said to be non-zero, which part is supposed to be non-negative. So once you solve those two problems, it tells you your correct answer, which is x less than or equal to 0, x greater than or equal to positive 4. So if you were combine them together, you have negative infinity through 0 and you have 4 through positive infinity. Again, if you don't know how to solve this inequality, please go back, revisit our class videos for section 1.1, or we can go over it together. You have to know how to solve an inequality. The next problem we have here is to do function composition. So the first one we have is f composite with g, so you plug g into your f function. So it's g of x plus 3, in other words, it's x to the x plus 3. If it had been the other way around, you are going to replace the x in your g function, so you have f of x to the power of f of x, so you end up with x plus 3. Like I said, it's a common practice to use a parenthesis to hold whatever you have to avoid misunderstanding. So the next one, f composite with g, is simply with g function substituted in replacing your x, so it's g of x plus h. In other words, it's x squared plus x plus h. G composite with f is the other way around, which means it's your input function squared plus your input function. In this case, it's f. Hence, you have x plus h squared plus x plus h. The next problem, the other way around, f composite with g. So whatever was inside your function should be now written as g, and I know g is supposed to be cosine of x. If we have flipped the order, it's the same idea. It's g function means cosine of whatever is inside. Therefore, you have cosine of sine of x. The last problem we have here, if you have f composite with g, it means you throw the x away, you write g at the position of f, so it's 2 to the power of 1/2. If it had been the other way around, you are trying to change every single x you see in the g function into f. Unfortunately, I didn't see anything, so this is what I'm supposed to get. Okay, So the last two piece is something which I said as optional, but I do think you want to have a general feeling about it. It's going to be useful in calculus. So basically the idea of thinking is what's the inside layer is supposed to be the function that's plugged in. So in the order of calculation tells you which is the inside layer, which means that comes first, and what's the outside layer. So if you do this, you realize you need to find x plus 2 first before you take square root. If you had written it as g composite with f, what's inside the parentheses is your f, what's outside your g. So your f function is x plus 2. Your g function, of course, doesn't make sense if you say it's square root. You want to have something to hold the position for you, so it's square root of x. So if it had been the other way around, as f composite with g, what's inside is the parentheses, which is the inside layer, in this case x plus 2. Your f of x is a square root function. Similar idea, if you had f composite with g, what's inside is your g function, so your g of x is x plus 3. The outside layer, which I said already, but you can think about it, it's something to the power of 4. You want to have something to hold the position for you, so it's x to the power of 4. The last problem is of similar idea. If you want to write it as f composite with g, where g is the inside layer, so that's what something in the parentheses has 2 plus x. Therefore, the outside layer is what's left. It's sign, and then you should have your x there. The last problem we have here, I put it last because it has 3 layers. I want you to think about your order of calculation. You need to know what's x plus 5 first. Then you raise it to the power of 3, and eventually you find the reciprocal of it. The order of calculation, the first term is the most inside layer because it's going to be equivalent to A composite with B composite with C. So the most inside layer is the first thing to handle. The parenthesis tells you that handled first, and then the second step, and eventually the last step. Hence, C of x is the most inside layer, B of x is that thing cubed, and A of x is telling you please flip it. Okay, so this is what I end up with.